Hello and welcome to topic E, the first part where we're doing some problems and exercises by hand and just running through the calculations most basic way. You have your own calculator. I'll use mine, but some sort of hand calculator to concepts that we learned. Hey, introducing bivariate statistics and the various numerous ones there are. So I have two questions that I want to look at. The wording here could be a little better when I looked at it ago, but I'm here to explain it, so it'll be okay. A case control study of 1,700 participants looked at the association between smoking and lung cancer. The study included 689 cases of lung cancer, and of those smoking, there were 139 cases smoking and 58 of the controls, those that don't have lung cancer, also still smoke and not get lung cancer. So I want to just do everything we discussed last time, all the statistics we can calculate. And we start with the 2 by 2 table. Just check if I'm recording. Yes, the 2 by 2 table. So for consistency, I try to have my risk factor as the rows. So that'll be smoking is the risk, and that's of course a yes. Oh, like my lines somewhat decent here. Tool, lines, but that's okay. So I also, I missed a line. Whoopsie. There we go. Okay. Then of course I'll have some totals here. And then also I have the outcome. Oops. In this case, lung cancer that we're investigating. The people diagnosed with lung cancer and some were not. These are the cases, and I don't want to just look at people with lung cancer. I want to mix in some people that didn't have lung cancer to see if smoking affects one group more than the other based on this. So I have a total column here as well and 1,700 my overall total. So I have 689 people that I'm including in this study that had lung cancer or has. Of the cases, 139 were smoking, so here, and 58 were oh, have lung cancer. And that should be enough to get me to fill in everything else. So I'll show some calculations here. First, we can finish the row of the smoking group. 139 plus 8. I'll have that random line pop up switching windows. That's okay. And then we can focus here on the ones that have lung cancer but didn't smoke. That'll be 689 minus 139. Now, these are just made up numbers. They're not taken from any actual study, but your sample of participants, of people that you're investigating, might not always give you the results that you are looking for, right? Do the study hoping for something, but you don't always get hope for. If the sample was, I'm just continuing filling this time, and do it with me. If your sample was representative of some community or the population at large, whatever you are trying to investigate, then hopefully these numbers and the corresponding probabilities will be estimates of the true underlying probabilities. Now, we could be investigating lung cancer here in a specific age group, in a specific area. Who knows, right? Those things aren't explained. So I'm just systematically filling in the missing numbers based on the totals that I have. Hopefully that made sense as I did it, showing the calculation as well, which I did. Oh, screen, yes. Uh, Not super difficult. Now, maybe I will and make a new page here so that we can jump back and forth and see. Let me just check my pen size. Yes. Jump back and forth. Just do my bad. Tablet just thought the other screen was my main screen. There we go. Everything's fine again. So I'll just jump back and forth here so we can look at the numbers and then we can write down everything we know to write down. I'll give them headings as well. Absolute risk. Now, of course, we have the exposed group. My pen is super big here. When I this is exposed, not risk factor, right? So we have our short ones here. Absolute risk of the exposed group, the absolute risk of lung cancer, that'll simply be the percentage of those that have lung cancer per the total that we're smoking. So given you're exposed to the risk factor, what is the percentage have lung cancer? Match this with the marital status and postpartum depression example, and we're really just copying that. So I have 139 out of 197. 130, and I'll make that a percentage. Previous example we did, it was 8 over 19, and we get 42%. In this case, it's going to be the same positioning of the numbers, but of course a different percentage. So we get 0.7058, I'll say, 558. So 5.6. That will lead us to 70.56% rounded. I just want a couple of decimals in my percentage, let's say 2 decimals, so I'll use 4 decimals in the decimal version. That means that 70%, roughly, 70% got lung cancer given they were smoking. Now I do have to, for the case of for the simplicity, I just need to remember the most accurate number. Said repeatedly that we can't, we should always use the most accurate number in a future calculation. So if this comes up, I guess I have to follow that rule, right? So many digits. Relevant, but I don't necessarily know. Anyway, I just want to keep track of everything. So the absolute risk of lung cancer in the not exposed group, that would be 550 B. 550 B. See what we get there. So it is a little slow. It is a little tedious to do everything by hand, but it's so nice. And we only saw one example last time. 659 if I round it. That leads to 36.59%. Perhaps I do need to keep track of all the decimals that I have in case I need to use this information, tedious as that may be. I have all these decimals and I see all those decimals. Your calculator might not see that many, perfectly fine in truth. After about 6 or so, they're not going to really affect us in these simple calculations. So it's all good. Okay, so now this already gives us the picture, and we'll paint that picture maybe more clearly for some readers, maybe ourselves, by calculating all the other statistics, but they're all built on this. Let me just fix my 6 here. I don't like it. So if you, this is what is this saying? And I'm just going to say it. I'm not going to write it out, but do scroll back in the video so that you clearly understand how to interpret all of these. If you smoke, then there's a 70% chance of getting lung cancer. According to this, remember this is an estimate of the true probability. Might be a little off, but we'll trust it. We have no choice. Take it as the probability. If you do not smoke, then you're not exposed to smoking. Then there is a 36-ish percent chance of getting lung cancer according to this information. Okay. So this definitely suggests that smoking is putting me at a greater risk. The rest of the statistics really is there to clarify or present this in a variety of ways. But technically, these are the only two numbers, really. So we'll all to practice. Next up, we have the relative risk. Relative risk, I'll call it RR, relative risk of lung cancer in terms of the factor, is simply going to be the ratio of the percentages or the decimal versions. If you take decimals, just make sure they're both the same. Now I write the rounded versions here, but we want to calculate using the most accurate versions we have, tedious as it is, but I'm going to have to type in all these decimals. Let's do it. Doesn't matter. In my calculation, I'll use the decimal version as long as I do the same thing for both. Oh, it's hard to divide by 0.5979. 1.92, I'll say 93. How many decimals? Around 4 decimals. 9282. And that leads me to a percentage. Some people don't like interpreting this percentage. They're not super comfortable, and you'll see in the part A video, I actually didn't interpret it because I distract you at that stage. And the decimal version here is, I'll say here, the number of times, let's say number of times worse for the risk factor, right? So if I interpret this, I could say, very similar to our previous video, that smoking causes my chances of getting lung cancer to be almost 2 times as much. Or, of course, you can use, I'm 2 times as likely to get lung cancer if I smoke. That is what this is telling me. Using a percentage to interpret this, my probability or chances of getting lung cancer is 192% of my chances not getting lung cancer. So I don't love the percentage interpretation here because people they aren't as comfortable with this version, but when I do the relative risk reduction, it's a little bit nicer to talk about an increase or a decrease. But still, it is there as an option. Then, in order to talk about risk reduction relative, I have to talk about the absolute risk reduction. First, ugly risk reduction. Same as we did that last time. And it's the difference between percentages. Like always, I'm writing the options, but in our calculation, we should probably use the most accurate version. Now, crucial to have all the decimals, but I won't necessarily know where I can cut it off. So best to be safe. Plus your calculator won't show all all of them. So I'm just subtracting the other one. And you'll see once we get to the spreadsheet, it's going to be much more convenient. So I kind of want to do this on purpose to appreciate the spreadsheet so much more. And accurate one, your calculation. Again, on your handheld calculator, you might not see this many things. The amount you have to write down is not that bad. Okay. Absolute risk reduction. What does that mean? That means that, in general, if I just ignore the smoking risk factor, there is still a chance of getting lung cancer. That chance is 36.59%. Exposed to the risk, I have a higher chance. So in addition to this baseline normal situation of 36.59%, according to this, there's 33.96% on top of that, my probability of getting lung cancer, or another 33.69% of the population gets lung cancer when they're smoking. So in the interest of saving time, I'm not writing down all of these interpretations. I will leave that to you. Write it down, see it, scroll back and forth, hear it again in the video, write down your interpretation. Then I have my relative risk reduction, and I'm just taking that absolute risk reduction, oops, 33, that's an ugly 3, 6% relative to the smaller, the baseline, if you. And we will, of course, use the most accurate numbers we have. So the top one is brackets there. Now I can use decimals versions, but then I have to do both, right? Since that's what I have written down here. And I'm dividing by something way up. This guy over here. But it'll make me appreciate what's coming up so much. Just like you eat something that's a little yucky, you appreciate the good stuff. 8.2%. I don't think I'm using this guy again, but no, I don't think I am. Now, of course, there was a shorter way to do this, right? I could have just taken the relative risk percentage and taken off 100%, because what the relative risk reduction is looking at is what is the increase in my chances relative to the baseline. So I didn't need to do all this, but it's good to know there are two ways. What if my calculation up there, relative risk, is wrong? It's maybe nice to not depend on that. Options. So though I am 2 times, my probability of getting lung cancer is 2 times greater if I smoke, the increase in my probability by smoking, my chances are increased by 92.82%. On top of the baseline 100%, that's going to happen anyway. Whether I smoke or not, there's a chance of getting lung cancer. But on top of that, my chances are increased by 92.82% if I smoked, if I'm exposed to the risk factor. Okay, so again, very important to be able to interpret these things. Let me just see how much space I have. I'd like to do everything on the page, and I think I can. Risk reduction. 2 more. Number needed to treat. Remember what that is. That used the fact that there is a percentage of the population that smoke that are going to get lung cancer, statistically speaking. But if they didn't smoke, it could have been avoided. If they were quote unquote treated and not exposed to the risk factor, that outcome of lung cancer could have been avoided. So the calculation is therefore based on the absolute risk reduction, which in our case is 33.96%. That's the percentage of the population on top of baseline, let's call it. So that is, oh, I should probably write down thing, right? Number, that's a lot of E's. Treat. Then we'll call it NNT. If I like the percentage version, I don't know, it just makes me feel better. So it's going to be 100 over the ARR percentage version, which is going to be 106. Of course, the accurate version, just in case it makes a little difference in a little decimal. I didn't realize it's so to know how. Sorry, I can't speak. Hold on, let me just type this in. 6, 4, 5, 9, 6. It's a very difficult problem to know how rounding errors propagate in future calculations. It depends on what those calculations are, how many, all kinds of things. 9, 4. That's almost 3. So if I round it up, that means I'm going to have to treat 3. So if I can take randomly 3 people that were smoking and I get them to stop smoking, I avoid one case of lung cancer. Of course, this is generalizing, statistically speaking, of course. But it's sometimes a very handy number to present. And again, it's based on the same numbers as all the other statistics. Just what do people interpret conveniently? What do they like to interpret? What makes the most sense to them in my presentation of my there's no right or wrong here. It's all based on the same table. And it can unfortunately be abused not by manipulating the information, that's a whole other issue, by taking outliers or things that aren't outliers and excluding them just so my numbers look good. That's definitely unethical. But still using the data correctly, just picking the statistic here that sounds the most impressive. It's best to look at a variety of them. They're all saying the same thing, but they're all. So let's just do the odds separately. The odds of getting lung cancer in the exposed group, I'll say it like this, is, now I look at my numbers here, it is 139 to 58, right? 8. And the odds, we're just going to fit this in, not exposed. Odds of getting lung cancer if you don't smoke, 550 to 953. 553. I like to write these out before therefore the left divided by the right. Not 950, 950. And what do we get? Those are the numbers from the table, so they're not rounded or anything. 150, I can type properly. 159 divided by 58. 7.4, say, rounded. And 550 divided by 953. 0.57, 0.58, I'll say. Okay. That is just, doing that division is not something I really like look at. I don't have a good intuition, an interpretation of these numbers at all. But technically, it's just standardizing the original odds ratio to be this number to 1. This. So I am much more likely this is very closely connected to the underlying same probabilities we calculated earlier, right? I'm much more likely to get lung cancer in the smoking group, not smoking group, which is why the odds of this first one is greater than 1 and so much bigger than the other one. And then my odds ratio, that's the last one we're calculating. It's simply the ratio of these odds in standardized form. And when I calculate it, I will use the accurate versions, which I have in my calculator. I think I can see them. Yeah, 2.74 divided by 0.2487. What do we get? Random line. I get 4.75. So again, we said in the previous video that if let's say effect of the risk factor is moderate to big, without classifying what moderate means, there's quite an effect. Then the odds ratio will be significantly bigger, noticeably bigger than the relative risk. Where was relative risk? Here, right? It was almost 2. And the odds ratio is almost 5 because based on this data, being exposed to smoking is quite increases your chances of getting lung cancer quite a bit. That initially, let's just review here. Initially, without looking at smoking or not, without looking at the risk factor, I was at 36%, and that jumped up almost double, which is what the relative risk says. Relative risk is by far my favorite. Very, I could tell this to someone and they would understand and have a good feeling of what that means based on their experience. That my chances double. If I tell them my chances of lung cancer double if I smoke. Very good chance that someone is going to perfectly understand what I'm saying, no problem. However, it's just depending on your audience, right? Because the general audience won't have a lot of experience with odds, but they will have a good sense of probabilities and chance. Whereas if I say my odds of getting lung cancer is almost 5 times more if I smoke versus not smoking, how do people interpret that? Chances are they're going to interpret odds in the same way as probability. To many people, the unfortunate reality, in my experience, is that odds are intuitively viewed to be the same as probability. So I could now take advantage of that as the author by presenting the odds ratio and nothing else. Then it sounds, oh no, I'm going to read as a reader, the casual reader or the uninformed, inexperienced reader, which is understandable. I'm going to read this as, oh no, I'm 5 times as likely to get lung cancer. The authors aren't being unethical. They're presenting the information, but, and technically speaking, it's not their fault if you don't understand odds, but it's not as commonly used in general. That if you don't have experience with odds versus probability and have built an understanding that these two things are not the same, they're very closely connected, but they're not the same. And we don't, in general conversation, talk about odds. We talk about probability and chance. So I have developed through my over my life a fairly good interpretation of that concept. I have not developed probably a solid and clear interpretation of odds. So it's very easy to present information that can be interpreted as much more impressive than it actually is, or different from reality. No one's fault necessarily. It is based on our experiences. So there we have it. I think this one example that runs us through all the different statistics we can calculate and how to interpret them gives us a better idea of what to do in this topic. Now we will move on to doing another example, but using a little bit more convenient calculator, which will be spreadsheet.